Hi guys, as I told you in my last video that this machine still needs some improvement to take full advantage of the working range in the Z-axis. I'm just going to break this into two steps. The first step is that I wanted to remake the spindle holding plate here, so I wouldn't be able to adjust the angle of the spindle this way or this way. So that way I can adjust the surface of the bit here to be parallel to the X and Y axis plane, and then afterward I can do all type of calibration. Once the machine is recalibrated, I can remove all the pieces here and put the new version back together. So I'm just going to start by making the new spindle holding plate. Now this plate is mute. I can just take the spindle out and put it on here and replace this plate. But as you can see last time, that's how fast and smooth it is to cut aluminum, so I'm not scared anymore. So I just got to make quickly two aluminum plate to put into the slot here to reinforce the back of this, so I can tighten the spindle a bit more. So let me just do that very quickly. It took only less than 5 minutes to cut out these two plates with 1mm step down and a 500mm feed rate. So it's almost like you cut wood on the 3018 CNC. So this is really like a big improvement compared to the old machine. I just installed the two plates of aluminum on here. Next step, I'm just going to take the spindle out, and then I will show you how I can adjust the angle of the spindle. The spindle is out, and before I install it back on here, I'm just going to explain very quickly how I will be able to adjust the angle with this plate. So as you can see here, it has 6 bolts here to fit this plate on, and I only have this one is a hole, and all the other 5 here are slots. Once I put this on here, I can rotate the plate here, adjust a little bit the angle. Just it will rotate around this center is this hole, and for the angle go this way, I can loosen those bolts and put the spacer between like those bolts or those bolts to tilt it this way or this way. So let me just do that very quickly. I have the spindle and the spindle plate marked on the machine. I was about to adjust the angle and I realized something. First of all, just I don't think that I need this bolt in the middle here. 4 of this will be enough. And I think that I will adjust the angle this way first, because I will have to loosen all the bolts and put the spacer at the back here of the plate. If I do the other way first, then when I loosen it, the spacer might fall off. And also to adjust the angle this way, I think that I should pre-tilt the spindle like this way, like this. When I adjust the angle, I know that it really tilts this way, so I only need to put the spacer like on top here at the back of the plate. So that way the spacer won't fall off when I loosen the bolt. So let me just take this out and put some washer at the back here, so to tilt it this way. I'm just going to put one extra washer on each of these bolts. To test the angle of the spindle, I just made this piece of stock is about 10 by 10 centimeter. So I'm just going to glue it on here on the platform. And then I'm just going to use this 20mm sport bit so I can run a face mill like through the x-axis first. The bigger the bit, the more it will amplify the angle of the spindle. So let's see how it looks like. I'm just going to do 0.5mm step down. Okay, so as expected, the spindle kind of tilts this way. So the line here, if you run your nail through this way, it's going to get stuck every time. If it tilts this way, if you run your nail, it will get stuck this way. The way I'm going to tilt it back is just I'm going to loosen all the bolts here, and then I'm just going to take this piece of a foil paper and I fold it a few times. And then I'm just going to slide this piece behind here between the plate and the washer, and then I'm just going to tighten it again and try again. And I'm just going to keep doing this until I have the flat surface here, just the nail doesn't get stuck anymore. Okay, this time it's really almost gone, like I can just barely feel it. If you use the smaller bit, I'm sure that you don't feel it. For me, I just going to do it one more time and hopefully it will be completely gone. This time I don't even see the line and I definitely cannot feel it. So I consider that this angle is adjusted. So now I just move on to this angle. My nail gets stuck a bit running this way. So I just have a bit of angle like tilt this way. So I only need to adjust a little bit. So let me just show you how I'm going to do it. What I'm going to do is just I'm going to keep this bolt tight and I loosen the other three. So the spindle will rotate like this. Around the center is this hole. That way I'm just going to use the hammer to tap here a little bit to turn the spindle like this way. And if the line works like the other way, I can just tap on this side. So let me just loosen the bolt. That's it, because I only have a little bit to adjust. If I have more line, I will tap a little bit more, and I keep repeating this until the surface is also like completely flat. Now I cannot really feel the line anymore. My nail doesn't get stuck this way or this way, so I consider this flat. Okay, so this calibration is a bit tedious and it takes a bit of time because it's the most difficult one. All the other calibration will be easy. If you wanted to know which calibration I need to do, just look at my previous video about the 3-axis CNC calibration trick for high precision cutting. So after the calibration, I'm just going to move on to mill all the new pieces for the X and Z axis. The cutting parameters for the new pieces on this machine is about 10 times faster compared to the 3018 CNC, combining like the maximum step down and also the feed rate. To install these new pieces on the machine, I'm just going to unbolt this side and replace this piece first and then this piece, so that way I don't really need to remove all the bars and every wire and everything. The next step is very simple. I'm just going to dismount the spindle and this gantry plate and replace the plate with the new one here, and that's it. I have these two new plates installed back on, so the whole new setup is ready. I have a lot more room to work with. In the Z-axis I have like about 8 centimeters, and I can move this tip of the spindle really close to the wasteboard. Let me just show you quickly. Okay, so the distance here between the nuts and the wasteboard is only about like 6 millimeters. And I can have any bits that dug really deep into this wasteboard. If you think this is too close, you can lift the spindle up in the bracket, but for me I prefer it to be this way. Now I'm really happy with the new setup. Next step, I just going to install some limit switch, so that way I won't break anything when running the machine. I will use 6 of these limit switches. They are really cheap, probably like $2 for 10 of them on AliExpress or on eBay. I will need to solder 2 wires to each of the limit switch, the common pin and the normally open, and all of the wire will be connected parallel to each other, go into only one input port on the control board. As I told you before, for me the most important limit switches will be on the Y-axis, so I'm just going to show you very quickly how I'm going to find the position to install those switches on the Y-axis. First step, I'm just going to move the Y-axis very slowly to the front until it reaches the limit and the stepper motor kind of lose step. For the front of the machine, the stepper will lose step when the bearing block hit this plate, so I'm just going to try to glue one of the limit switch on this bearing block. Now I'm just going to move the Y-axis a little bit back. I think just I will glue the limit switch about right here, about 4 millimeters back from the edge of the bearing block, so that way when the limit switch like click like this, so the wheel still like stick a bit in front of the bearing block, but I don't have much distance between the bearing block and the plate, so that way I don't lose much of the range in the Y-axis. As you can see here, the back of the machine is the same at the front, so I'm just going to glue the limit switch on here the same way. I have the limit switches installed on the Y-axis, X-axis and Z-axis. The Y and X-axis were easy. For the Z-axis is a bit different, just I had to glue on some piece of wood here so I can glue the limit switch at the place that I wanted. So now let me just show you how the limit switch work. I'm just going to move the Y-axis to the front here. As you can see here, the machine just stopped when the limit switch like click, and I have the safe distance here is about 3 millimeters, so that way the machine wouldn't be able to move like all the way forward and hit this plate when running, so it's not going to break anything. So now to move the machine back, I will have to override the limit switch in the software. Here in Match 3, to override the limit switch, you have to go to Setting tab and then just click on Override Limits and then click on Reset. So now you will be able to move the machine back and override the limit. Now once the machine moves back, the limit switch unclicked, this mode will turn off, so the limit switch will be back on again and you won't be able to go over the limit. And that's it. is unclicked and this light turn off. So now if I try to move it back again to go over the limit, it just stops the moment the limit switch clicks, so I just have to do it again. Now as you can see that all the limit switches are installed and working, I feel very confident running this machine that I won't break anything. So this setup I will keep for a very long time, I think. Next step, I just have to repeat all the calibrations. One of the viewers told me his trick to test the rigidity of the machine and also the precision. So I will show you his trick after all the calibration are done. The idea to test the rigidity of the machine, just I'm going to try to move all the axis by hand by pushing it like up and down, sideways, or front to back and back to front, something like that. So I'm just going to try on the Z axis first. I couldn't even move any axis, so I think just this machine passed the rigidity test. Next step is to test the precision of the machine. What I'm going to do is just I'm going to mill a piece of aluminum here and then measure the dimension later to see if it's accurate. I'm just going to mill a circle here with the diameter is 40 millimeter, and in that circle there will be a square with the size 20 millimeter. This piece of aluminum is 1/8 of an inch thick. I'm just going to try to cut very fast, 2.8 millimeter step down and 1200 millimeter per minute for adaptive clearing and 600 millimeter feed rate for 2D contour. So let's see how it goes. Okay, so I have the piece cut out here, so let's see how the dimension look like. So the outer diameter of the circle is about 40.1 millimeter, so it's about 0.1 millimeter off. Let's see how the side of the square here. It's about 19.7 millimeter, so it's a bit undercut. I think that I went a bit too fast on the 2D contour because the side here doesn't have the shiny looking like this part. So if I go a bit slower, I think the precision would be better. So let me just try again. I have the piece recut here. Let's see how the dimension look like. Now I'm about 0.02 millimeter off. So for a hobbyist machine, I think this precision is more than acceptable. For the second cut of this piece, just I didn't leave any rest for the adaptive clearing, and for the 2D contour I just do 2 steps down. The first one is 2 millimeter. The second one is 1.2 millimeter. So the edge here is really clean. It's kind of shiny here. So I think the cut worked really good and smooth. I don't think that I need to do a lot of upgrades on this machine. Except maybe the spindle is really large. If I have more money, I can buy something quieter, like the water-cooled spindle. And if I have even more money, I might buy some of the thick aluminum plate to replace all the pieces here with aluminum. So the machine will become really sturdy and the precision will be improved. And maybe just to make the workflow a bit easier, I might install some of the homing switch in the future. But for now, I'm really happy with this machine. It has a lot more room to work with. It can mill anything I want a lot faster compared to the 3018 CNC. So this is really a good upgrade.